Ever pondered the veracity of the theory of evolution? Picture this, a theory that has been widely accepted, yet carries with it some hidden inconsistencies. Today we're going to explore the chinks in the armour of Darwin's famous concept. We'll unearth the inadequacy of the fossil record, the conundrum of irreducible complexity, the clash between punctuated equilibrium and gradualism, the insufficient explanation for inheritance mechanisms, and the murky forces directing evolution. Join us as we delve into the top 5 reasons the theory of evolution may not be as foolproof as it seems. Firstly, let us scrutinize the fossil record, often hailed as concrete evidence for evolution. The fossil record, a vast collection of evidence buried within the Earth's crust, is often paraded as a testament to the theory of evolution. But upon closer examination, this record is far from complete, and its gaps are not small, they are yawning chasms. Darwin's theory of evolution hinges on the concept of gradual change. Yet the fossil record does not show a slow, steady progression of simple organisms evolving into more complex ones. Rather, it reveals a sudden explosion of fully formed species appearing out of nowhere. Consider the Cambrian explosion, a period when a staggering variety of complex organisms suddenly appeared in the fossil record, with no precursors. How does one explain this abrupt appearance of a multitude of species, each with distinct, complex structures? The theory of evolution, with its gradualism, falls short in providing a satisfactory explanation. Furthermore, the fossil record is notably lacking in what should be abundant, transitional fossils. These are the fossils of organisms that serve as the missing links, the stepping stones from one species to another. These transitional forms are critical to the narrative of evolution, yet they are conspicuously absent. Where are these elusive missing links? And then there are the so-called living fossils, species that appear in the fossil record as fully formed and then continue unchanged into the present day. The coelacanth, a prehistoric fish thought to have gone extinct 65 million years ago, was discovered alive in the 20th century, virtually unchanged from its fossil ancestors. How does the theory of evolution account for these instances of stasis? Evidently, the fossil record presents more questions than it answers, casting a shadow of doubt on the theory of evolution. And as we delve deeper, we'll see that there are more reasons to question the theory of evolution. Next, we examine the concept of irreducible complexity. In the grand tapestry of life, there exists a multitude of biological systems so complex and intricately knit that their functionality is entirely dependent on each and every component playing its part flawlessly. This concept, my friends, is known as irreducible complexity. A system is irreducibly complex when it requires all of its parts to be present and functioning correctly in order for it to work. In other words, if you were to remove even a single component, the entire system would cease to function. Let's consider the humble mousetrap as a simple example. A mousetrap consists of several parts: the base, the catch, the spring, the hammer, and the holding bar. Each part is essential. Remove the spring and the trap won't snap. Take away the base and there's nowhere to mount the other parts. Without all of these components working in harmony, the mousetrap is rendered useless. Now let's apply this concept to the biological world. Take, for instance, the bacterial flagellum, a microscopic rotary motor that allows bacteria to move. It's made up of several protein parts, all of which are necessary for its function. If you remove even one part, the flagellum stops working and the bacterium loses its ability to move. But here's the rub. The theory of evolution posits that life evolved gradually over millions of years, with each new feature or trait developing slowly, incremental step by incremental step. But how can this be reconciled with the concept of irreducible complexity? How could something like the bacterial flagellum, which needs all of its parts to be present and functioning correctly at the same time, have evolved gradually? The answer is we don't really know. And that's the point. Irreducible complexity presents a puzzle that the theory of evolution as it currently stands struggles to solve. It suggests the existence of systems that could not have evolved gradually, posing a stark contradiction to the central tenet of gradualism in evolutionary theory. The existence of irreducibly complex systems, therefore, poses a significant challenge to the theory of evolution. Thirdly, we explore the contentious issue of punctuated equilibrium versus gradualism. In the grand theatre of evolution, two key players vie for the spotlight: punctuated equilibrium and gradualism. These two theories stand at opposite ends of the spectrum, each with its own version of how species evolve over time. Gradualism, as the name suggests, posits that evolution is a slow, steady process. It's like a painter meticulously adding brushstrokes to a canvas over a long period, gradually creating a masterpiece. This theory suggests that new species evolve slowly, with subtle changes accumulating over millions of years. On the other hand, punctuated equilibrium is the rebel. It argues that evolution isn't a slow, monotonous process, but rather a series of rapid bursts of change interspersed with long periods of relative stability. It's more akin to a playwright who spends years in quiet contemplation, only to pen the entire script in a frenzy of creativity. However, the fossil record, our window into the past, does not neatly align with either of these theories. The smooth, progressive changes predicted by gradualism are often missing from the fossil record. On the other hand, the abrupt changes suggested by punctuated equilibrium are also rare to find. The fossil record, it seems, is playing a game of hide-and-seek, refusing to fully support either theory. Moreover, the question of what triggers these periods of stability and change remains unanswered. If evolution is indeed punctuated, what causes these sudden bursts of creativity? If it is gradual, why does the fossil record not reflect this slow, steady pace? These questions create a cloud of uncertainty that hangs over the theory of evolution. They hint at a puzzle that is far from complete, a story that is still being written. The conflict between punctuated equilibrium and gradualism, and the lack of clear evidence for either, adds to the growing list of challenges facing the theory of evolution. The lack of a unified explanation for the pace of evolution adds another layer of uncertainty to the theory. Fourthly, we delve into the theory's insufficient explanation for inheritance mechanisms. As we all know, the principle of inheritance is the cornerstone of evolution. It is the process by which characteristics or traits are passed from one generation to the next. Yet the theory of evolution struggles to provide a comprehensive explanation for how this crucial process actually works. It's a bit like trying to bake a cake without knowing the ingredients or the method. The theory does an excellent job explaining that traits are passed down, but when it comes to the how and the why, things get a bit murky. Let's consider the role of genetics in evolution. Genetics is the language of inheritance, the code that determines everything from our eye color to our susceptibility to certain diseases. But how does this genetic code change over time to result in the diverse species we see today? The theory of evolution suggests that it's due to random mutations. But are we to believe that the intricate complexities of life, the elaborate dance of nature, is all down to random chance? Furthermore, the theory of evolution fails to account for the interplay between genetics and environment. It's well established that environmental factors can affect gene expression, a phenomenon known as epigenetics. Yet the theory of evolution seems to gloss over this crucial aspect, treating genes as static entities rather than dynamic ones that can adapt and change in response to their environment. This brings us to another point of contention: the notion of inheritance of acquired characteristics. This idea, which suggests that traits acquired or lost during an organism's lifetime could be passed on to the next generation, is largely ignored by the theory of evolution. Yet, recent studies in the field of epigenetics suggest that this might not be as far-fetched as it sounds. In conclusion, while the theory of evolution provides a broad-brush picture of inheritance, it fails to delve into the nitty-gritty details. It's like a jigsaw puzzle with several missing pieces. The theory's incomplete understanding of inheritance mechanisms further weakens its credibility. Lastly, we consider the unclear directing forces of evolution. The theory of evolution fundamentally asserts that species change over time in response to environmental factors. However, it falls short in clearly identifying what these driving forces are. Is it survival of the fittest? Is it random mutation? Is it sexual selection? Or is it a combination of all these factors? The ambiguity not only raises questions but also undermines the credibility of the theory. If we don't fully understand what is steering the course of evolution, how can we claim the theory as an absolute truth? This lack of clarity muddies the waters and leaves room for doubt, questioning, and alternative theories. The theory of evolution, while widely accepted, is not without its ambiguities and uncertainties. The unclear directing forces of evolution add yet another flaw to the theory. This begs the question, how much do we really know about the process that supposedly shapes the life on our planet? In conclusion, we see that the theory of evolution, while influential, is not without its flaws. The gaps in the fossil record, the unexplained intricacies of irreducible complexity, the debate between punctuated equilibrium and gradualism, the vague understanding of inheritance mechanisms, and the elusive directing forces of evolution all cast doubt on its credibility. These 5 reasons illuminate the cracks in the theory of evolution, urging us to question and reassess what we think we know about our origins.